Hello again and welcome back to the next lecture. Now we're going to take a look at inner classes. So let's get started. Let's look at simple uses of inner classes. Inner classes are classes which are defined within other classes. The class that includes the inner class is called the outer class. There is no particular location where the definition of the inner class, or classes, must be placed within the outer class. Placing it first or last, however, will guarantee that it is much easier to find. An inner class definition is a member of the outer class in the same way that the instance variables and methods of the outer class are members also. An inner class is local to the outer class definition, and the name of an inner class may be reused for something else outside of the outer class definition. There are two main advantages to inner classes. They can make the outer class more self-contained since they are defined inside of a class, and both their methods have access to each other's private methods and instance variables. Using an inner class as a helping class is one of the most useful applications of inner classes. Here is an example of an inner class. As you can see in the code, we have our public class outer, and then within that outer class, we have that inner class. Inner and outer classes have access to each other's private members. Within the definition of a method of an inner class, it is legal to reference a private instance variable of the outer class. It is also legal to invoke a private method of the outer class. Essentially, the inner class has a hidden reference to the outer class. With the definition of a method of the outer class, it is legal to reference a private instance variable of the inner class on an object of the inner class, and it is also legal to invoke a non-static method of the inner class. This is as long as an object of the inner class is used as a calling object. Let's take a look at another class within an inner class. Here in the code, the modifier private in this line should not be changed to public. However, the modifiers public and private inside the inner class, money, can be changed to anything else, and it would have no effect on the class bank account. The definition of the inner class ends here, but the definition of the outer class continues into part 2 of this display. To invoke a non-static method of the inner class outside of the inner class, you need to create an object of the inner class. This invocation of the inner class method getAmount would be allowed even if the method getAmount were marked as private. Notice down here that the outer class has access to the private instance variables of the inner class. This class would normally have more methods, but we have only included the methods we need to illustrate the points covered here. Let's take a look at referring to a method of the outer class. If a method is invoked in an inner class, if the inner class has no such method, then it is assumed to be an invocation of the method of that name in the outer class. If both the inner and outer class have a method with the same name, and the intent is to invoke the method in the outer class, then the following invocation must be used. Now we're going to be shifting to public inner classes. If an inner class is marked public, then it can be used outside of the outer class. In the case of a non-static inner class, it must be created using an object of the outer class. Note that in this code, the prefix account must come before new. In the case of a static inner class, the procedure is similar, but simpler than that for non-static inner classes. Note that all of the following are acceptable. When considering a public money inner class, if the money inner class in the bank account example was defined as public, we can create and use objects of type money outside of the bank account class. Feel free to try out any of the code that you see in this lecture also, and play around with it to see how inner and outer classes truly work. When it comes to static inner classes, a normal inner class has a connection between its objects and the outer class object that created the inner class object. This allows an inner class definition to reference an instance variable, or invoke a method of the outer class. There are certain situations, however, when an inner class must be static. If an object of the inner class is created within a static method of the outer class. Since a static inner class has no connection to an object of the outer class, within an inner class method, instance variables of the outer class cannot be referenced, and non-static methods of the outer class cannot be invoked. To invoke a static method, or to name a static variable of a static inner class within the outer class, preface each with the name of the inner class and a dot. A class can have as many inner classes as it needs. Inner classes have access to each other's private members as long as an object of the outer inner class is used as the calling object. The .class file for an inner class works to the fact that compiling any class in Java produces a .class file named classname.class. Compiling a class with one or more inner classes causes both or more classes to be compiled, and produces two or more .class files. We have two examples here, such as classname.class and classname_innerClassName.class, with a $sign in the middle. Nesting inner classes. It is legal to nest inner classes within inner classes. The rules are the same as before, but the names get longer. Given class A, which has public inner class B, which has public inner class C, then the following is valid and it is legal to use. Inner classes and inheritance. Given an outer class that has an inner class, any derived class of the outer class will automatically have inner class as an inner class. In this case, the derived class cannot override the inner class. An outer class can be a derived class, and an inner class can be a derived class also. We also have anonymous classes. If an object is to be created, but there is no need to name the object's class, then an anonymous class definition can be used. The class definition is embedded inside the expression with the new operator. An anonymous class is an abbreviated notation for creating a simple local object, inline, within any expression, simply by wrapping the desired code in a new expression. Anonymous classes are sometimes used when they are to be assigned to a variable of another type. The other type must be such that an object of the anonymous class is also an object of the other type, and that other type is usually a Java interface. Let's take a look at some code of an anonymous class. This is just a toy example to demonstrate the Java syntax for anonymous classes. If you'd like to, also feel free to type out this code and go along as we run through the code as well. This code shows that this is still the file anonymousclassdemo.java. Here we have a sample dialog. This is the file numbercarrier.java. Also, feel free to practice any of these if you want to. That is the end of this lecture. I hope you're enjoying the class, and remember to keep practicing and keep posting in the discussion so we can see what you're up to and how you're doing with the course. I'll see you next time.